So today we are making a deadlift procedurally in geometry nodes. It's not that hard, it's quite easy and it takes a few nodes. So let's start with importing our reference image. We will use the reference image to match the proportions of the lifting bar, which will be the first part of the modeling. So let's go to the geometry nodes and add a new geometry node group. So the first node we will add is the curve line node. And first thing we need to do is adjust the length of the curve. So let's type the length of the lifting bar and divide it by 2. And because the lifting bar is symmetrical, we'll create only the first half of the lifting bar and then mirror it on the other side. So we use transform geometry to align the curve with the lifting bar reference. Now we need to add a thickness to our curve. So we will add two nodes. First will be set curve radius and the second one will be resample the curve. And make sure that you are resampling the curve with at least 100 points because we will need the geometry later. But we cannot add a thickness without converting the curve to the mesh. So add convert to mesh node, and for the profile curve we will use a curve circle. Now if we hide our reference, we can see that our curve has a thickness, which we can procedurally control with the geometry nodes. But now we have the challenge to recreate the elevation, because the profile of the lifting bar is not the same on all parts. If I outline the lifting bar with a grease pencil, you can see the profile that we need to remake and apply for the curve in order to get the same result. Now luckily for us there is a simple way how we can do this. We will add some additional nodes, so we need to first make space in our group. Let's continue with adding a spline parameter node. Basically this node will give us a black and white gradient texture from the start to the end of this curve. And to control this gradient, we will use RGB curves plugged into the radius socket. You can now see that the curve radius is matching the profile of the RGB curve. Now it's just about accuracy and matching the proportions of the lifting bar with the curve dots. Remember that you want to use the sharp curve fall off so you don't have any smooth transition between the dots. And if you feel like your curve needs more resolution, you can increase the amount of points. With that you can get closer to the reference. For more efficient workflow, you can copy the coordinates of the dots and paste it back to get the same elevation. Now as you can see, we have successfully matched the dimensions and the proportions of the lifting bar. But we have only the first half and we need to mirror it on the other side. So add join geometry and transform geometry nodes. So connect the node to the node group and then rotate the first part on the z-axis by 180 degrees. Also join the original geometry, and now you have the fully procedural lifting bar. As I said before, if you think that the resolution is too small, you can increase the point count. If you do so, you will end up with sharper edges. The last final touch is adding a merge by distance node. This will merge the overlapping vertices that are in the center of the lifting bar. Also, make sure that you have checked fill caps feature to ensure that the curve is closed. Now the bar is finished and we need to make the weight plates. I'm gonna add a cylinder with 64 vertices, rotate it on the x-axis and scale it down. I was looking for the dimensions of the 44-pound plate on the internet, and this is what I found, so if you want to copy the same numbers, feel free to do so. To make a hole inside the plate, duplicate the cylinder, scale it down, and then run a boolean operation with the difference. Now the plate looks really simple, so I need to make some details in the modeling, so insert some faces, extrude it inwards, insert again, and make a center. To add even more detail, add a bevel modifier to smooth the corners and add some reflections. Make the amount really small and increase the segments. It's still kinda simple and fast, but I think for the reference this plate is more than enough. Now for the next steps, I will be using the most recent version of Blender, which is 4.01, because we will be using repeat nodes that are only available in the most recent version of Blender. So add a repeat group and connect it to our node group. And the purpose of this repeat zone is that the repeat zone will allow us to control the amount of plates that we will have on our lifting bar. So in simple words, we will create an array modifier in geometry nodes. So add join geometry node inside the repeat zone, then add an object info node with the plate selected as an object, and also a transform geometry node, because first we need to rotate the plate. Also make sure that these two nodes are outside of the repeat zone, otherwise the effect won't work. To be honest, I was slightly confused because this was my first time using this new feature, but at the end I finally found out how to place the nodes in order that they are working as an array modifier. So here is the screenshot of the final node group, And as you can do inside the array modifier, you can now control the distance between the individual plates, the array axis, and of course the number of plates, which controls the iteration value. Now we will connect both parts with join geometry node, and we will move the plates to the right side with transform geometry node. Just a tip for you, if you hold shift while adjusting the value, the sensitivity drops down and you can be more accurate with the movement. Now we will do the same process as we did for the bar. So we're gonna add a transform geometry node and join geometry node, join them together, and then we will use the transform geometry node to rotate the plates to the other side of the bar, which is the same as before, 180 degrees. And now we are finally finished with our modeling. And because the whole thing is procedural, you can add how many plates you want. Now for the quick texturing, I'm gonna unwrap the cylinder with projecting from view, and then I will add a plate image as an image texture. And because the shape is the same, just align the UV map. And for the bar, I will just use the principled BSDF with metallic slider set to 1 and low roughness to get that nice and shiny reflection. And there you have it, a procedural bar with weights. I hope this video was useful for you. Also check out my other videos on my YouTube channel. You can support me with subscribing to this channel or sharing this video to others. And with that being said, I will see you in the next video.